There is like a very famous programming problem in binary search. If you know binary search required, but its prerequisite is that the array should be sorted, right? But what happens now? Ki you are not going to find array every time array will not be sorted, right? So there is a variation in a binary search that is called as a circularly sorted array or a rotated array. Okay, so we will solve one problem on it. So suppose we have given this array, okay, 4, 5, 6, 7, 8, 9, and 10. So if we say we have to rotate this array one time, so 10 comes at front. That means train travel like this here, right? And all the elements from here will be pushed up in the front. Okay. That's 4. Yeah. So all the elements will be pushed further. So if we rotate once, so 10 only comes from the sorted array in front. If we rotate twice, so also 9 will come here. Okay, 9 will come in front of 10. So this is called two-time rotated array. Okay, or the other name is circularly sorted array also. So the question is how many times is sorted array rotated? So suppose you have given this array, you have to tell how many times this array is rotated. Okay, so there will so let's see the approach we will following to solve this problem. Okay, so if you can see this, okay, so case one will be array of low should be less than array of y, so return low. What does it mean? If suppose array of low at index 0 is smaller than array of high at index n minus 1, that means if 4 is smaller than the last element, that means array is already sorted. So we'll return the low. So what is the index of low? Is 0. That means array is rotated 0 times, right? Then we will find our mid element. Okay. After that, we are going to use next and pre of mid element, previous and next element. So there is one unique condition in rotated array, okay, that requires this next and previous element of mid. That means if you can see this 4, the next element to the after a 4 is greater than, and the last element from the mid is also greater than mid element. Okay, to, if this condition is satisfied, that means this is the place from where our remaining subarray is already sorted. On the left side, the other half is already sorted. So this is the only position, okay, where array is not sorted, right? So if we found this 4, that means we have found the number of rotation. Okay, so we simply return 2. So if you can see 4 on what place it is, index 0, 1, 2, 2. So how many times is rotated? 2, right? So basically that's what we are doing here, and we will return our mid. Okay, so the special condition was array of mid should be less than next, and array of mid should be less than previous, so return mid. Okay, then apart from that, there are these our simple cases like all binary search. So we will jump into our coding. Okay, so let's code it up. So I have taken this array itself. Okay, so okay, 10, okay, let it be this. Okay, so I will create one int n equals to array of array length minus array of array length. Okay, and I will create one static int where return type will be int count. Okay, okay, how many times is our array rotated? It will going to take integer type array. Okay, and it will going to take our integer n, the length of an our array. Okay, so in basically what happens, we always have our low equals to 0, right? And then we always have our what we have, I equals to n minus 1. N is length of the, right? and after that we don't need anything else. Okay, so while low is okay less than equal to high, this is our like main motto of a binary search. Okay, we will in binary search we divide into the half, right? So we will find first condition. If you know what is the first condition for this, what is the first case? If array of low is array of is less than array of high, that means our array is sorted. So if array of low that okay less than equal to array of high, that basically means our array is sorted and it is not rotated. So just simply return low. Okay. If this condition is not satisfied, then we have to find our int mid. Okay. So we basically discussed it previously also. Okay, how why we are doing this. Okay. We can also do low plus start. Okay. To find the sorry start minus low or whatever you can do. Low plus like start and divide by 2 also, but I prefer doing like this 2. So we got our mid. Now we want our next element to the mid, right? So we will do mid plus 1 mod by n. Sorry, it should be 1. Okay, and int. Now you will be seeing why is I am doing like a mid, right? So if we do mid plus 1, it goes to the next element from the mid. If I do mid minus 1, so what will happen? Where was that? Mm, one second. Okay. Uh, when we do this, we have to do mod n. Okay. After dividing, we will it is to overcome the overflow. Okay. Or reduce the overflow. So now we will check our this will be like unique condition. Okay. Unique condition. Okay. Because it's the case 2. Okay. Case 2 is unique where the next element to the mid will be greater and also the previous element to the same time will be greater than the mid. So mid should be less than equal to array of next at the same time, and array of mid should be less than equal to array of previous. Okay. So if this happens, just simply return what we have to return here. We have to return mid because we have to find the point where things are uh, found the signs until the array is rotated. Okay, the next thing will be array of array of mid. So now basically the case 3, right? We can see what will be the case 3. Mid should be always lesser than high. If this both condition on upside is failed, then we will go to the this case. Okay, it's basically the normal binary search after the second case. Okay, high. So what we do, I equals to mid minus 1. Else you just have to do low equals to mid plus 1. Alright, and we will just if nothing's happened, we will return minus 1. Okay, now we'll call our int. Instead of it, we will just call it out. Okay, What was the function name over? Count. We pass array, right? After we will pass n, right? And we just have to run this code to see if we got our answer or not. Okay. If you can see, array is rotated 2 times, right? 9, 10, and then the sorting actually started, right? It is also sorted, so it is called circle to sorted, and our answer is 2, right? So that's it for this video. See you in the next one. Okay.